Hello everyone, welcome back. We're going to do some additional examples, one that I think we did in class and maybe a few that we did not, to go with our chapter 6 part 2. So before we get started on examples that we're going to do together, we're going to look at if there's any extra help with some guidance that you would like. You can go to the Algebra Review Guide. Review guide that was given out at the beginning of the year, and specifically for what we're going to do today, you might want to look at problems 119 through 130. Again, you can find a blank copy of that in your modules, as well as a completed one to see how the steps to solve some of those went. But for today, we're going to look at sections that we did was part 2, but in your book it was, I think, 6.4 through 6.5. So I think we reviewed this example in class, but I want to start it here today. We're going to look at reciprocal and fractional exponents. So the first example we're going to use is when we have 8 to the 2/3. This is fractional and a reciprocal exponent. So one of the first things that we found to do with this, in order to simplify this, remember, when it's fractional, it talks about the root, and when it's reciprocal, you think it looks like this. It would be, we would have 8, would it be to the 3rd root, but the whole thing would be squared. But there's an easier way to simplify these, which we talked about, and we're going to do right now. That easier way starts with putting 8 into its prime factorization, and that is the product of primes. So 8 into its prime factorization, 2 is a prime number, but its factor is 4. 4 is not yet prime, and 4 turns into 2 times 2. So we've hit the bottom. We can go no further with prime numbers, and we can see that 8 is base power 2 raised to the 3rd. That is its prime factorization. So now we can substitute 2 to the power 3 for 8 in this problem. So let's do that. We have 8 raised to the 2/3. When we substitute in, we can say that 8 becomes 2 to the power 3, that's its prime factorization, raised to the 2/3 power. Now here, we would use our knowledge of fractions and power of a power property to evaluate this. The power of a power states that we can multiply. So we can have our base, we can have 3 times 2 to the 3rd. Now we'll use our knowledge of fractions. This tells me that it becomes, when you multiply 3, it's 3 over 1 times 2 over 3. These cancel, and you end with 2 over 1. That is multiplying fractions. So when I put that into, with our base, we end up having 2 to the power 2, which we can simplify as 4. So the solution of 8 raised to the 2/3 power is 4. Great when it's simple. Let's look at a much more complicated number. Let's look at 216 raised to the 4/3 power. Again, we're going to put 216 into its prime factorization, which when it's an even number, I start with an even one. So this would be 2, and then it would be 108. And then that's even again, so let's divide that by 2, and that's 54. I know 54 is not prime, so I need to keep going. It's even, so let's make that 2 and 27. This is not even. Let's use 3. So 3 and 9, and 9 is not yet prime. I know that's 3 and 3. So now when you look at all the prime numbers here, we see that 216 in its prime factorization is 2 to the power 3 times 3 to the power 3. That is its prime factorization. So now we'll do the same thing that we did before. We have 216 raised to the power 4/3. Now I'm going to substitute its prime factorization in, and you'll see that it's 2 to the 3 times 3 to the 3 raised to the power 4/3. Now we know from our power of a product and power that we can, and our agreement that states that if it's going to be applied to both bases, there need to be parentheses, and I see parentheses here, so we can distribute that power in. So we would have 2 to the 3rd times 4/3 times 3 to the 3rd raised to the 4/3 multiplied by. Using our fraction math, I know that this becomes, this is over 1, this is over 1. Multiply those out, and we have 2 to the 4 times 3 to the 4. Now let's simplify this one all the way. I know that 2 to the 4 is 16, and I know that 3 to the 4 is 81, and this would equal 1,296. That's its simplest form. Pretty easy, right? It's that prime factorization. You have to make sure that every time you end over here with a prime number. We can't have anything left that is still divisible by anything else. It needs to be its full prime factorization. Let's look at one more example for this one. We're going to look at when we have 256 raised to the 1/6 power divided by 64 raised to the 1/4 power. So there's a few steps that we need to do here. Our step 1 is we need to put 256 and 64 into its prime factorization. Let's do that right here. So 56, I know, is 4 times 64. We'll use that 64 part again. We'll make this easy for ourselves. 4 is not prime and 64 is not prime, so we'll need to break these both down. 4 breaks down into 2 and 2, which we know those are both prime. 64 will start with 8 times 8. And I know that 8 is 2 times 4. 4 is still not prime, so this one is 2 times 2. And I can use that again. 2 times 4 and 2 times 2. And now I know that it is these, every tree here ends in a prime number. But don't forget this one. If you don't only go by 2s like we did before, then you'll need to make sure that you count all of those. So 256 in its prime factorization is 2, 1, 2, 3, 4, 5, 6, 7, 8, 2 to the 8th. Now we're going to use the 64 side again, and we're going to say that is 8 times 8. And we're going to say those break down to 2 and 4, and then 2 and 2. And here it is 2 and 4, and then 2 and 2. So we'll circle those. And we see that 64 is equal to 2. Whoops, don't forget that one. 1, 2, 3, 4, 5, 6. 2 to the 6th. Now, we will then use what we did before, our step 2. Is we will substitute the prime factorization for the whole numbers in the original problem. So substitute. Substitute the prime factorization for the whole numbers in the original problem. Now let's remember our original problem is 256 to the 1/6 divided by 64 to the 1/4. Let's substitute in our prime factorization. So we see it's 2 to the 8 to the 1/6 divided by 2 to the 6th to the 1/4. Now, our step 3 is use our exponential properties and simplify. And simplify. We're going to use our quotient of a power with 2 bases. We're going to use our power of a power and our knowledge of fractions. So let's work on these. Let's simplify. So I know that I can distribute that 1/6 to that using power of a power. So that would give me 2 to the 8 times 1/6, which I know over 1. My fractions show me that this would be 2 to the 8 over 6. I can simplify this one further, which would be 2 to the 4/3 if we wanted. And I would say is divided by, we'll distribute this one and multiply it across, 2 to the 6th times 1/4, which also would leave me with 2 to the 6 over 4. And simplified further would give me 2 to the 3/2. Now, when I use quotient of, now that I have 2 bases, I can put this in the form like we had done at another time. I can put this in the form of 2 to the 4/3 divided by 2 to the 3/2. And remember, when you have the same bases, you can subtract these. So let's subtract them. This gives me 2 to the 4/3 minus 3/2. Now this uses my fraction math, and I cannot subtract without having a common denominator. So I'm going to multiply the first fraction by 2 and the second fraction by 3. This would give me, let's just look at the fraction. Fraction part, not the exponential part. So 4 over 3 minus 3 over 2. Multiplying the first one by 2 gives me 8 over 6. And multiplying the second one by 3 gives me 9 over 6. Now I can subtract because they have the same denominator, which would give me negative 1 over 6. Now I can apply that to the base 2. That would give me 2 to the negative 1/6. Now we know that when it is a negative exponent, it belongs in the denominator. So we will say this is equal to 1 over 2 to the 1/6. And because it's now in the denominator, it is positive. Now be very, very careful. This is not 1 over 2 to the 6th. That is not the same thing as 1 over 2 to the 1/6. Make sure if it's fractional, it remains fractional, not an exponent. Hopefully this will help you further understand using our fractional exponents and our reciprocal exponents, and even a little bit better, our negative exponents. If you have any questions, please reach out. Otherwise, I hope you have a great rest of the day.